Hello everyone. In this lecture we are gonna study in depth the automotive engine. As we all know, the engine provides the power to drive the vehicle's wheels. All automobile engines, both gasoline and diesel, are classified as internal combustion engines because the combustion or burning that creates energy takes place inside the engine. The biggest part of the engine is the cylinder block. The cylinder block is a large casting of metal that is drilled with holes to allow for the passage of lubricants and coolant through the block and provide spaces for movement of mechanical parts. The block contains the cylinders, which are round passageways fitted with pistons. The block hoses or holds the major mechanical parts of the engine. The cylinder head fits on top of the cylinder block to close off and seal the top of the cylinder. The combustion chamber is an area into which the air-fuel mixture is compressed and burned. The cylinder head contains all or most of the combustion chamber. So the cylinder head also contains ports through which the air-fuel mixture enters and burned gases exit the cylinder and the bore for the spark plug. The valve train is a series of parts used to open and close the intake and exhaust parts. A valve is a movable part that opens and closes the ports. A camshaft controls the movement of the valves, and the springs are used to help close the valves. The up and down motion of the pistons must be converted to rotary motion before it can drive the wheels of the vehicle. This conversion is achieved by linking the piston to crankshaft with a connecting rod. The upper end of the connecting rod moves with the piston. The lower end of the connecting rod is attached to the crankshaft and moves in a circle. The end of the crankshaft is connecting to the flywheel or flexor plate. So we'll talk right now about engine classifications. As we all know, today's automotive engines can be classified in several ways depending on the following design features. Operational cycles. Most technicians will generally come in contact with only 4-stroke engines. However, a few older cars have used and some cars in the future will use the 2-stroke engine. Number of cylinder. Current engine designs include 3, 4, 5, 6, 8, 10, and 12 cylinders engines. Cylinder arrangement. An engine can be flat, opposite, inline, or V-tube. Other more complicated designs have also been used. Also, we have the valve train type. Engine valve train can be either the overhead camshaft, OHC type, or the camshaft in a block, overhead valve, or OHV type, and some engines separate camshafts for the intake and exhaust valves. They are based on the OHC design and are called double overhead camshaft or DOHC engines. V-type DOHC engines have 4 camshafts, 2 on each side. Ignition type. There are 2 types of ignition systems, spark and compression. Gasoline engine uses spark ignition system. In spark ignition system, the air-fuel mixture is ignited by an electrical spark. Diesel engine or compression ignition engines have no spark plugs. A diesel engine relies on the heat generated as air compressed to ignite the air-fuel mixture for the power stroke. Also, cooling system. There are both cooled and liquid-cooled engines in use. Nearly all of today's engines have liquid cooling system. Fuel type. Several types of fuel currently used in automobile engines include gasoline, natural gas, methanol, diesel, and propane, and the most commonly used is gasoline, although new fuels are being tested. So the four-stroke gasoline engine in passenger car or truck, the engine provides the rotating power to drive the wheels through the transmission and driving axles. All automotive engines, both gasoline and diesel, are classified as internal combustion because the combustion or burning takes place inside the engine. These systems require an air-fuel mixture that arrives in combustion chamber at the correct time, and an engine constructed withstand the temperatures and pressures created by the burning of thousands of fuel droplets. So the combustion chamber is the space between the top of the piston and the cylinder head. It's an enclosed area in which the fuel and air mixture is burned. So the piston fits into a hollow metal tube called a cylinder, and the piston moves up and down in the cylinder. And this reciprocating motion must be converted to a rotary motion before it can drive the wheels of vehicle. This change of motion is accomplished by connecting the piston to a crankshaft with a connecting rod, and the upper end of the connecting rod moves with the piston as it moves up and down in the cylinder. The lower end of the connecting rod is attached to the crankshaft and moves in a circle, and the end of the crankshaft is connected to the flywheel, which transfers the engine's power through the drivetrain to the wheels. In order to have a complete combustion in an engine, the right amount of fuel must be mixed with the right amount of air. The mixture must be compressed in a sealed container, then choked by the right amount of heat, which is the spark, at the right time. So when these conditions exist, all the fuel that entered the cylinder is burned and converted to power, which is used to move the vehicle, and automotive engines have more than one cylinder. Each cylinder should receive the same amount of air, fuel, and heat if the engine is to run efficiently. Although the combustion must occur in a sealed cylinder, the cylinder must also have some means of allowing heat, fuel, and air into it. There must also be a means to allow the burn air-fuel mixture out so the fresh mixture can enter and the engine can continue to run. So in order to accommodate these requirements, engines are fitted with valves. There are at least two valves at the top of each cylinder. The air-fuel mixture enters the combustion chamber through an intake valve and leaves after having been burned through an exit valve. The valves are accurately machined plugs that fit into machined openings. So a valve is said to be seated or closed when it rests in its opening. When the valve is pushed off its seat, it opens. A rotating camshaft driven and timed to the crankshaft opens and closes the intake and exhaust valves. Cams are raised sections of the shaft that have high spot called loops. Cam loops are oval shaped, and the placement of the loop on the shaft determines when the valve will open. The height and shape of the loop determines how far the valve will open and how long it will remain open in relation to piston movement. So the camshaft rotates, the loop rotates and push the valve open by pushing it away from its seat. Once the cam loop rotates out of the way, the valve forced by spring closes, and the camshaft can be located either in the cylinder block or in the cylinder head. So when the action of the valves and the spark plug is properly timed to the movement of the piston, the combustion cycle takes the place in 4-stroke of the piston, and the intake stroke, the compression stroke, and the power stroke, and the exhaust stroke, and the camshaft is driven by the crank shaft through gears or sprockets and cogged belt or timing chain, and the camshaft turns at half of the crankshaft speed and rotates one complete turn during each complete 4-stroke cycle. So we have the 4-stroke cycle. A stroke is the full travel of the piston either up or down in a cylinder's bore, and the reciprocal movement of the piston during the 4-stroke is converted to a rotary motion by the crankshaft. It takes 2 full revolutions of the crankshaft to complete the 4-stroke cycle. 1 full revolution of the crankshaft is equal to 360 degrees of the rotation, and therefore it takes 720 degrees to complete the 4-stroke cycle. During 1 piston stroke, the crankshaft rotates 180 degrees. The flywheel, we have the flywheel. As we know, flywheel, the piston moves by the pressure produced during combustion, but this moves the piston only about half a stroke or 1/4 of a revolution of the crankshaft. This explains why flywheel is needed. The flywheel stores some of the power produced by the engine, and the power is used to keep the pistons in motion during the rest of the 4-stroke cycle. A heavy flywheel is only found on engine equipped with manual transmission. Engines with automatic transmissions have a flex plate and a torque converter. The weight and motion of the fluid inside the torque converter serve as a flywheel. The intake stroke, which is the first stroke of the cycle, is the intake stroke. As the piston moves away from the top dead center, the intake valve opens, the downward movement of the piston increases, and the volume of the cylinder above it, reducing the pressure in the cylinder, and the reduced pressure, commonly referred to as engine vacuum, causes the atmospheric pressure to push a mixture of air and fuel through the open intake valve. So some engines are equipped with a super or turbocharger that pushes more air past the valve. As the piston reaches the bottom of the stroke, the reduction in pressure stops, causing the intake of air-fuel mixture to slow down. It doesn't stop because the weight and the movement of the air-fuel mixture. It continues to enter the cylinder until the intake valve closes, and the intake valve closes after the piston had reached bottom dead center or BDC. This delayed closing of the valve increases the volumetric efficiency of the cylinder by packing as much air and fuel into it as possible. The compression stroke begins as the piston starts to move from BDC. The intake valve closes, trapping the air-fuel mixture in the cylinder, and the upward movement of the piston compresses the air-fuel mixture, this heating it up. At the TDC, the piston and cylinder walls from the combustion chamber and which the fuel will be burned, the volume of the cylinder with the piston at the BDC compared to the volume of the cylinder with the piston at TDC determines the combustion ratio of the engine. And we have the power stroke. The power stroke begins as the compressed fuel mixture is ignited. With the valves is still closed, an electrical spark across the electrodes of a spark plug ignites the air-fuel mixture, and the burning fuel rapidly expands, creating a very high pressure against the top of the piston, and this drives the piston down towards the BDC, or bottom dead center, and the downward movement of the piston is transmitted through the connecting rod to crankshaft. We have the exhaust stroke. The exhaust valve opens just before the piston reaches the BDC on the power stroke. So the pressure within the cylinder causes the exhaust gas to rush past the open valve and into the exhaust system. Movement of the piston from BDC pushes mostly of the remaining exhaust gas from the cylinder. As the piston nears TDC, the top dead center, the exhaust valves begins to close as the intake valve starts to open. The exhaust stroke completes the 4-stroke cycle, and the opening of the intake valve begins the cycle again. This cycle occurs in each cylinder and is repeated over and over as long as the engine is running. The firing order, as we know, an engine's firing order states the sequence in which an engine's pistons are on their power stroke, and therefore the order in which the cylinder's spark plugs fire. The firing order also indicates the position of all of the pistons in an engine when a cylinder is firing. For example, consider a 4-cylinder engine with a firing order of 1, 3, 4, 2. The sequence begins with pistons number 1 on the compression stroke. During that time, piston number 3 is moving down on its intake stroke, so the number 4 is moving up on its exhaust stroke, and number 2 is moving down on its power stroke. These events are identified by where it needs to happen in order for number 3 to be ready for fire next, and so on. So the firing order of an engine is determined by its design and manufacturer's preferences. So an engine's firing order can be found on the engine or on the engine's emissions label and in service manual. We'll move right now to study the 2-stroke gasoline engine. In the past, several imported vehicles have used 2-stroke engines. As the name implies, this engine requires only 2-stroke of the piston to complete all 4 operations: intake, compression, power, and exhaust. This is accomplished by follows. First, movement of the piston from the BDC, bottom dead center, to TDC, top dead center, completes both intake and compression. The second, when the piston nears TDC, the compressed air-fuel mixture is ignited, causing an expansion of the gases. During this time, the intake and exhaust ports are closed. The third steps, expanding gases in the cylinder, force the piston down, rotating the crankshaft. And the fourth, with the piston at BDC, the intake and exhaust ports are both open, allowing exhaust gases to leave the cylinder and air-fuel mixture to enter. So although the 2-stroke cycle engine is simple in design and lightweight because it lacks a valve train, it has not been widely used in automobiles. It tends to be less fuel efficient and release more pollutants into the atmosphere than 4-stroke engines. Oil is often in the exhaust stream because these engines require constant oil delivery to the cylinders to keep the piston lubricated, and some of these engines require a certain amount of oil to be mixed with the fuel.